I received this cute machine very recently. What is so intriguing about this machine is that you just place an ice block below it, it will start to rotate. What is even more intriguing is that if I replace this ice block with a cup of hot water, it will again rotate but in the opposite direction. This interesting device is known as a Stirling Engine, invented by Mr. Robert Stirling long back. To understand how does this device work, or how was Mr. Stirling's mind work at the time of this invention, as usual, let's get into 3D animation.
It's hard to believe that the mere presence of a constant low and high temperature can result in a pulsating motion like this one. But then along comes the genius mind of Robert Stirling. To start, separate the hot and cold plates with an insulating material. Let's introduce a thick insulating cylinder called a displacer for this purpose. If the displacer is at the bottom, it will obviously prevent the heat flow from the bottom plate, which means the majority of the air undergoes a heat transfer with the upper cold plate and the air volume approaches the surrounding air temperature. If the displacer is moved up, the exact reverse will happen and the air will heat up. When the air temperature inside this volume increases, its pressure also increases. Robert Stirling's next brilliant idea was to use this high pressure to run a power piston. The same power piston can move the displacer up or down. Let's see how he achieved it practically. To achieve this objective, Robert Stirling connected one more crank on the same rotating shaft of the power piston, this time at a 90-degree offset to the first crank. Now, this crank is connected to the displacer. He also added a flywheel in the shaft, the use of which we will come to know later. Now, let's see how these arrangements achieved Robert Stirling's objectives when the bottom plate of the engine is heated up. Let's start with the power piston's lowest position. If you check the position of the displacer here, it is almost in the middle. The air obviously gets heated, so its pressure increases, which moves the piston up. Let's rewind and see this motion once again. Just observe what the displacer is doing. Clearly, during the piston's upward motion, the displacer moves up and supports the additional heat from the hot plate. The displacer prevents the cold plate heat transfer during this motion, which means that during the piston's upward motion, the air's temperature and pressure keeps increasing and the piston extracts the energy. However, after reaching the top, you can see that the displacer is again in the middle, which means that the heated air can lose heat to the cold plate. Obviously, this process reduces the pressure of the air volume. Due to the momentum of the big flywheel, the piston will now start its downward journey, during which the air loses progressively more heat and pressure. Therefore, the piston's downward motion happens without much difficulty. After the piston reaches the bottom position, we are back at the starting point and the cycle repeats. It's a beautiful way of producing reciprocating motion, isn't it? Now, you can predict how this machine will behave if we keep an ice block below it. Here, the inside air temperature and pressure become lesser than the atmospheric temperature and pressure. The low pressure inside the chamber means the force acting on the piston will be in a downward direction, so the piston has to move down. This way, the engine rotates in the opposite direction. In short, this engine will keep on working unless and until there is a temperature difference between the two plates. The greater the temperature difference, the greater the engine's speed and power output. Stirling engines have amazing energy conversion efficiency, so why don't we use these types of engines in our cars? The main reason is that Stirling engines are slow to respond to varying power demands. To vary power output from a Stirling engine, you have to control the upper and bottom plate temperatures, and temperature controls always take time. Moreover, Stirling engines are heavier and costlier compared to their counterparts. However, we believe that the Stirling engine can be an ideal candidate for solar power extraction. The Maricopa solar power plant, commissioned in 2010, was based on Stirling Engine technology and was capable of producing 1.5 megawatts of electricity. This project was later abandoned due to environmental concerns. Let's hope that modern engineers will find a suitable application for Robert Stirling's genius invention. Please don't forget to support us, and thank you for watching the video.